Hello, Miss Minna here. Hope that you're all doing well. This is the November 2023 paper 3 video. I'm making this because I didn't have enough time on the weekend, as I told you, and some of you told me that you struggle with some of the questions. Definitely the hardest out of the 3 papers of this series. So I'm going to go through quite a few questions that I thought were tricky, and hopefully this is useful for you. Let's start off with question number 7. Okay, so Riley travelled by car and by aeroplane. He travelled 143 miles by car at an average speed of 55 miles per hour. Okay. He then travelled for 5 hours and 20 minutes by airplane. Work out in hours and minutes Riley's total travelling time. Okay, so because this is a distance, speed, time question, I'm first of all going to draw my triangle, which is this. And because it is in multiple steps, I'm going to draw out my distance, speed, time. And I've got a car and I've got an aeroplane. Okay, so let's do the car first of all. I've got my distance, which is 143 miles, and my speed, which is 55 miles per hour. So to work out my time, I'm going to do distance divided by speed, so 143 over 55, which gives me 2.6. Now, this is in hours, and the question wants me in hours and minutes. So let's convert this into hours and minutes. So first of all, how can I write this as a fraction? Well, this is 2 6/10 of an hour. So how many minutes is 6/10? Well, there are 60 minutes in an hour, so 6/10 of 60. You can work that out as 36 minutes. So actually this is 2 hours and 36 minutes. So let's put that into my table. And then it says he travels for 5 hours and 20 minutes by airplane. So I can just put that in my table. And I can add those together quite easily to get 7 hours and 56 minutes. So the hardest part of this question was converting that time into hours and minutes. So if I give you another one, let's say I gave you 1.3 hours, what would that be in hours and minutes? Pause the video for a second. Well, you do the same thing. That is 1 3/10 of an hour. And 3/10 of 60 that's going to give me 18. So this would be 1 hour and 18 minutes. So worth practicing those conversions between hours and minutes. Next question. The diagram shows a solid cube placed on a horizontal table. So it's another pressure, force, area question. It tells me the pressure is 3.5 and it tells me that the force is 504. Show that the total surface area of the cube is less than 900 centimeters squared. Okay, so let's type those into my equation. So I've got pressure 3.5 equals force 504 over my area. So how do I figure out what that area is? Well, if I multiply by area on both sides, I get 3.5 times by my area. 3.5 times area equals 504. And then I can divide by 3.5 to get the area is equal to 125 centimeters squared. So let's think on the diagram. What does that actually mean? Well, the area that is in contact with the table is this face of the cube here. That area is 125 centimeters squared. But I want to find the total surface area. So how many of those faces do I have in a cube? Well, I've got 6 and they are all the same. So if I multiply that by 6, I get 750 centimeters squared, which is less than 900 centimeters squared. So I just needed to think about, once I had the area, how would I find the total surface area? Well, I would just multiply that by 6 in this case. Okay, question 11. This was a tricky one. So the floor plan of a house is drawn using a scale of 1 to 50. On the plan, a room in the house has a floor area of 48 centimeters squared, work out the real area of the floor of this room, give your answer in meters squared. Okay, so we haven't done a whole lot of this. So how do I convert from centimeters squared to meters squared? Because it is not times by 100. That will be the conversion from centimeters to meters. Well, to help me out with this, I can draw a little picture. So here are two squares, the same area. The first one has an area of 1 meter by 1 meter, so 1 meter squared. And I'm going to make that equal to another square that's got an area of 100 centimeters by 100 centimeters. So if I do 100 times 100, I get 10,000 centimeters squared. So this is your conversion between meter squared and centimeter squares. And you can also do the same thing if you want to convert from centimeters cubed to meters cubed. Okay, so I've got that conversion, and what do I have in the on the plan? Well, I've got 48 centimeters squared. So I want to find out what that is in meters squared. How do I do that? Well, to get from centimeter squared to meter squared, I need to divide by 10,000. So dividing 48 by 10,000, I get 0.0048 meters squared. Okay, so in the plan, the floor has an area of 0.0048 meters squared. But then I need to use my scale, which is 1 to 50. Now, if I think about what that scale actually is, I think that that is my length scale factor from 1 to 50. But what I'm actually interested in is my area scale factor. So my length scale factor from 1 to 50 is just times by 50. And how would I get my area scale factor? Well, I would square that to get 1 to, what's that going to be? 2,500. So that is my actual area scale factor. So now to go from my plan to real life, I'm going to multiply that by 2,500, my scale factor, to get an answer of 12 meters squared. So really tricky one that, but let's keep going. Okay, question 12. Hopefully this was an okay question. I'm just going through it because it's a good question. This kind of question comes up quite often. So it says the diagram shows a shaded sector POQ of a circle with center O, radius 6.2, and it tells me what the area is, and it wants me to find the size of the angle. So I can see clearly that this is a reflex angle. It's going to be 180, probably something like 200, 230. So that should be like a rough idea of my answer. Okay, well, I know my formula for area of a sector. It is my angle, which is x, I don't know, out of 360. That's the fraction of the sector that is shaded, of times the area of a full circle, which is pi times radius squared, but my radius is 6.2, and I'm going to make that equal to 82.6. And now there's just an equation I need to solve. So first of all, times by 360, and I get x times pi times 6.2 squared equals 29736. And then I'm going to divide by pi, and I'm also going to divide by 6.2 squared. So I get my answer x, which is, to three significant figures, 246, which seems about right. I said it was about 180, probably about just over 200, so that seems like the right answer. Okay, let's keep going. Okay, this question here, very tricky question. The diagram shows triangle ABC and triangle AED. And I got some lengths that I've been given, and I want to show that they are similar. So let's first of all highlight ABC. There's ABC. Different color for AED. And what I like doing with these questions is drawing out my triangles separately. So let's draw out triangle. Let's do the smaller one first. AED. So I'm going to draw it like this. ADE. So that's 32, that's 21.6. And then ABC, the bigger triangle, A, B, and C. So if I think about my total side lengths here, 32 plus 22 is 54, and 21.6 plus 58.4 is 80. Now, I need to show that if two triangles are similar, their lengths are scale factors of each other. But it's not necessarily the case that, that this side and this side are scale factors of each other. What I need to consider is actually not the 54 and the 32, but the 32 and the 80. Essentially, the triangles have been flipped, but that's okay. They're still going to have the same scale factor. So what is that scale factor going to be? Well, if I want to go from 32 to 80, what am I going to multiply by? Well, I'm going to multiply by 80 over 32, which is equal to 2.5. And let's just check that works for the other one. What's the scale factor from 21.6 to 54? Well, that is also 2.5. So I'm just going to write a conclusion, which is that since AE and AB have the same scale factor as AD and AC, the triangles are similar. And that's all I need to do for those 2 marks. Okay, let's keep going. So question 16, this was a nice question. Zia has to set a 4-digit security password on her phone. Each digit of the passcode is a number from 1 to 9. She can use each number more than once. She tells her friend that the first digit is a cube number, second is a prime, third is greater than 6, the fourth is an odd number. There is one possible 4-digit passcode. Amber's going to have one attempt at guessing passcode, work out the probability. So my answer is going to be a probability that Amber guesses the passcode on the first attempt. Okay, so the way I like to lay out these questions is I like to figure out for each of the numbers, how many possibilities are there? So this first number here is a cube number. Well, what are the cube numbers? So the first one is 1 times 1 times 1, which is just 1. Then it's 2 times 2 times 2, which is 8. Then it is 3 times 3 times 3, which is 27. But of course, it just has to be a 1-digit number. So the only possibilities for the first digit are 1 or 8. Second one, prime number. What are all the prime numbers? Well, 2, 3, 5, and 7. Third digit is greater than 6, so that could only be 7, 8, 9. And the fourth one is odd, so 1, 3, 5, 7, and 9. So how many total possibilities are there? Well, there's 2 for the first one, 4 for the second one, 3 for the third one, and 5 for the final one. And if I multiply them together, there's 120 possibilities in all. What's the question though? The question is work out the probability that she guesses the code. Well, she's got one attempt. There's 120 possibilities. So I think the likelihood is out of 120, just 1. Okay, let's keep going. Okay, question 19, the frustum question. So lots of information here, let's unpick it. The diagram above shows frustum F of a cone. The frustum is made by removing a cone with height 10. Okay, I don't see that on the diagram. So the cone that we're removing has height 10 centimeters from a solid cone with height 15 and diameter 24. So the whole of the big cone, as we can see, is 15 centimeters. Then it says a solid S is made from removing F. So this thing here is that frustum F from a solid hemisphere as shown in the diagram below. Okay, the hemisphere has diameter 24 centimeters. Calculate the volume of solid S. So what is going to be our strategy here to find out the volume? Well, my final step, I think, is going to be to work out the volume of this, the whole shape, which is the hemisphere, half a sphere, and I'm going to take away this kind of frustum shape. Not a very good diagram, but I'm going to take away the frustum to find out what is left. So I think my first step is to find the volume of the frustum. Okay, so let's have a look at the diagram of the frustum. I know that to find the volume of the frustum, my technique is going to be to do the volume of the big cone. So I'm going to use the formula that's been given, 1/3 pi big R squared, big H for the big radius and the big height, minus 1/3 pi little r squared, little h. Now, which of those do I currently have? Well, I have got the radius of the big cone, which is 12. I've got the height of the big cone, which is 15. I don't think I have the radius of the smaller cone, so I need to work that out. But I do have the height, which is 10. So how do I find the radius of the smaller cone? Well, I need to use scale factors. So I think the scale factors that I need to look at is how do I get from the height of the big cone, which is 15, to the height of the small cone? I'm going to multiply by 10 over 15, or 2/3. So to get the radius of the smaller cone, I'm going to do the radius of the big cone, which is 12, times by my scale factor, which is 8 centimeters. So that radius there is 8 centimeters. Okay, so now I can plug in my numbers. So I've got 1/3 pi 12 squared 15 minus 1/3 pi 8 squared 10. And if I put that all into my calculator, I get 1,591.7 centimeters cubed. Okay, so that's the volume of the frustum. The rest of it is should be fine. So the second thing I'm going to do is I'm going to find the volume of the hemisphere. Okay, so I know the volume of a full sphere. It tells me in the formula box up here. But what is a hemisphere? Well, it is half of that. So it is a half of 4/3 pi r cubed. But I know what my radius is of my hemisphere. Gives me the diameter. So my radius is 12 centimeters. So it's going to be a half of this thing here. And if I put that into my calculator, I get 3,619.1 centimeters cubed. And then my final step, as we said before, I'm going to take away the bigger shape. I'm going to take away the smaller shape from the bigger shape. The bigger shape is the hemisphere. And I'm going to take away the volume of the frustum. And I get my answer, which is 2,027, which to three figures, 2,030 centimeters cubed. So we'll go over frustrums in one of the online revision sessions that I'm going to do. But in basically every frustum question, you need to think, what am I missing? And what is the scale factor that helps me to find my missing length? Let's move on to the next question. Okay, this question here, question 21. I've got a circle theorem question. A, B, C, and D are points in the circumference of the circle. AC is a diameter of the circle. Okay, we're going to use a sneaky circle theorem in this question, but that diameter is important. AD and BC are straight lines. Work out the size of angle BDC. So this angle here is what I want to find out. Okay, so the first thing I see in this question is this 35 degrees. And I know an angle which is equal to that using what we nickname the bow tie theorem, which is that angle there. So that angle there is 35 degrees. And we can't use the bow tie theorem in the exam. We have to say angles in the same segment are equal. Okay. So what next? What next? How am I going to use this 28? Well, let's think about it. I actually think there's a triangle that we can use to find another angle. Let me highlight this triangle now. So I can use the 35 that I just found and the 28 to find this big angle here, because I've got 35 plus 28, which is 63, and take that away from 180, which is 170 degrees. So this whole angle here is 170 degrees. But what this question relies on is using the fact that I've got a diameter here. So with the risk that my diagram gets a bit too crowded, let's go back to my highlighter. Whenever you see a diameter, it's very likely that you're going to use this circle theorem. So this triangle here that I've shaded is actually right angled. It's right angled because I've got a diameter, and it's a right angle because it is an angle in a semicircle. So this is equal to 90 degrees because angles in a semicircle are 90 degrees. So if that angle is 90 degrees, then so is this angle on the other side of the straight line. And so hopefully you should be able to see how I'm going to find that smaller angle. Because if I just draw out just this angle here, so I've said that this angle is 90. I want to find that angle, but this whole angle was 117 degrees. So to find out that angle, I'm going to subtract 90 from 117 to get 27 degrees. So that was a sneaky question there, but the lesson is whenever you've got a diameter, you need to think about angles in a semicircle and look out for that right angle. Okay, a couple more questions to continue with. Okay, question 22. Again, lots of words here, lots of worded questions here, but let's have a look. So, Ebony makes some bracelets to sell. The materials to make all the bracelets cost 190, correct the nearest £5. Okay, so this is definitely a question about bounds. So let's start looking at our number lines and doing our bounds. So to the nearest 5, so I'm going to go up 5, down 5, and find out the numbers in the middle. Do the same for the sales of the bracelets, doing this quite quickly, quite messily, but we are good at this. And it's also got the total time, 72 hours, correct to the nearest hour. Okay. Great, so here are all of the bounds that I need to consider. And it says hourly rate of pay equals total selling price minus total cost of materials over total time taken. The minimum hourly rate of pay for someone of Ebony's age is 8.20. By considering bounds, determine if Ebony's hourly rate of pay was definitely more than £8.20. Okay, so what I need to do next is I need to work out my hourly rate of pay. And let's actually find out both the upper bound and the lower bound, and then we'll see what we get. So what is the upper bound? Well, the highest amount of total pay, I'm going to take the highest selling price, which was 877.5, and I want the lowest cost of materials, so 187.5, divided by the lowest time taken, because I want to divide by the smallest number to get my biggest answer, which is £9.65. And for the lower bound, I'm going to do my opposite. So I'm going to do 872.5 minus 192.5 over 72.5, which is £9.38. So that's the lowest salary that she could have, which is actually the one that I'm interested in, because I want to show that this is definitely more than £8.20. So my conclusion would be her rate of pay is more than £8.20. And that is my answer. So hopefully we were able to at least make a start on that question by thinking about bounds. Okay, final two questions, question 23 next. Okay, we have got an equation here, so let me just write up this equation a bit bigger. And I want to find the ratio x to y. So hopefully what you did as your first step was you cross multiplied, because you got an equation with fractions. So you had 11 times by 2x squared plus y squared equals 43 times 4x squared minus y squared. And multiplying out brackets here, you get this. And then we're going to do some rearranging to clear it up. So let's move this minus 43y squared onto the other side. And then let's move this 22x squared, onto this side here. So I get 54y squared equals 150x squared. Let's just write it again up here. Now, I don't like all of these squares, but before I deal with that, let's move this 54 onto this side here. So I've only got numbers on one side. So what does that give me? Well, calculator tells me is 25 over 9x squared. So what do I do next? Well, I've got y squared equals 25 over 9x squared. So how am I going to deal with all of the squares? Well, I've got y squared on one side, x squared on the other side. So if I think if I square root everything, I am going to get rid of the squares. So what do I have? I've got y equals, well, the square root of 25 over 9 is just 5 over 3. And the square root of x squared is x, not x squared. Okay, so now I've got an equation for y in terms of x. Probably what I want to do here is multiply by 3 to get rid of the fraction. So 3y equals 5x. Now, how do I put this in terms of a ratio? Well, you're going to use a really nice technique here, which is to say, okay, let's say x was equal to, what would be a nice number? Let's say if x was equal to 3, well, what would y be? 5 times 3 would be 15, so therefore y would need to be 5. And then that gives me a ratio, my ratio x to y, which is 3 to 5. And that is my final answer. And of course, you could check that if you subbed it back into the original equation to check that it made sense. Final question. The diagram shows a triangular prism with a horizontal rectangular base ABCD. M is the midpoint of AD. Okay, so that's in the diagram. The vertex T is vertically above M. We've got AB equals 14.7. BC is equal to 3.8. So let's add these on the diagram. And MT is equal to 2.3. P is the point on AB such that AP to PB is 5 to 2. So where is P going to be? somewhere there. Calculate the size of the angle between TP, okay, so let's draw that line TP, and the base ABCD of the triangle. So let's draw that line connecting P to M, because that point is on the base of that triangle. So we need to find out this angle here, theta, and that, of course, TMP is a right angle. So what I really need to find, I think, is a couple of lengths on this triangle so that I can use some trigonometry. Okay, so I think the first thing I'm going to do is I'm going to find out these lengths using AP to PB. So what do I do here? Let's draw a bar model to represent. This is step one. I'm going to find AP. So this whole length here from A to B is 14.7, but it is split into 7 parts. 1, 2, 3, 4, 5, 6, 7. And AP is 5 of those parts. So I think to find out what each part is worth, I'm going to do 14.7 divided by 7, which gives me 2.1. So that gives me AP, which is 10.5, and PB, which is 4.2. So let's add that on the diagram, that AP is 10.5, and P to B is 4.2. But I think that A to P is what I'm more interested in. Okay, so I think I'm closer to finding a length in this right angle triangle that I need. So let's switch colors again. I think that I know that A to D is the same as B to C, which is 3 to H. And because M is the midpoint, A to M is half of that, 1.9. So I now think I've got this right angle triangle at the bottom here, which is MAP. I've got two of the lengths, 10.5 and 1.9. So I think I can find this length MP. I think I can find this length MP using Pythagoras. So do this nice and quickly. We're going to have 1.9 squared plus 10.5 squared equals x squared. Add them together and square root. You're going to get x is equal to 10.6705. Being careful not to round too early. So let's add that on the diagram, 10.6705. Now I think I've got all that I need, because if I highlight this triangle, I need to find the angle, and I've actually got two sides already. I've got this side that I just found out, 10.6705, but I've also got the height, 2.3. So I think my final step is just to use trigonometry in this triangle TMP, where I want to find out this angle here, theta. I've got the height, which is 2.3. I've got this length here, just found out. And let's label the sides. So I got, what do I have here? I have got my hypotenuse, I've got my opposite, and I've got my adjacent, so I'm going to be using tan. So let's continue this up here. I've got tan theta equals 2.3 over 10.6705. And I'm going to put that in my calculator, shift tan 2.3 divided by 10.6705. So inverse tan of that thing there, and I get my answer, which is 12.2 degrees to 1 decimal place. Okay, so that was a nice 3D trig problem there, nice difficult question to end the paper. Hopefully this was useful. As ever, give me a shout if there are any questions that I didn't cover that you would like me to go through. See you tomorrow.